Welcome to EDU World Space.
In this problem, we're given an alloy that's 80% copper, 20% zinc, and its density, and we're asked to find the molality of zinc. Students struggle with this kind of problem because they feel like they don't know how much they're working with, and what you have to realize is that these are concentrations. It doesn't matter if you have 1 cubic centimeter of this alloy or a whole ton of this alloy. The concentrations are all going to be the same. So let's, for the sake of simplicity, and you can pick any amount that you want, but for the sake of simplicity, let's assume that we have 1 cubic meter, that's a 3, of the alloy. If we have 1 cubic meter of the alloy, then we know that we have 8,750 kilograms, right? Because that's its density. So I found that using the density. So if that's my total mass, then I can find how much mass corresponds to the copper and how much mass corresponds to the zinc. Now remember that for molality, what I need is moles of solute. In this case, copper is the solute. And the solvent is the zinc because there's more zinc. Sorry, I have that backwards. The copper is the solvent. That's what I was trying to say. The copper is the solvent, and the zinc is the solute. Okay, so if we know that the total mass is 8750, then that's in kilograms. Then we know that 20% of that is zinc. So I'm going to write that as a decimal. That means that the mass that is zinc is equal to 17,050 kilograms. Now, I need moles of zinc, and I have molar mass in grams per mole, so I'm going to change this kilograms to grams, multiply by 1,000. It's an outrageously large mass, but remember that we're trying to pick numbers that are easy to work with. So 1,750 multiplied by, that's how many grams we have. We're going to divide by the molar mass of zinc. If we look up our periodic table, that's 65.38 grams of zinc for every 1 mole of zinc. This is zinc. And what we find is we have 26,770 moles of zinc. I know that looks outrageous. That's only because we picked a meter cubed, and that's a big number, and it's okay. So that's our zinc, that's our solute. Now we're going to find our solvent. Similarly, if our total mass is 8,750 kilograms, the portion that corresponds to copper is 80%, so 0.800 is the percent that is copper. That's equal to 7,000 kilograms. And remember that for molality, we need kilograms of solvent, so we already got what we need there. So this is kilograms of copper. And now we have moles of zinc, kilograms of copper. So we're going to write the molality as 26,770 moles of zinc divided by 7,000 kilograms of copper. That's equal to 3.82 molal, that's a lowercase m, zinc. where molal stands for moles for every kilogram. Then in part B, similarly, same scenario, but now we're asked to calculate the molarity. And molarity, you'll recall, is moles of solute over liters of solution. So again, the moles of solute we already found. The moles of solute we already found, that came out of the part A. So we're going to keep the same number of moles of solute. That's the 26,770 moles of zinc. Now we need the volume of the whole solution. This is relatively straightforward. We already found that the volume we assumed was 1 meter cubed. Now we need to change 1 meter cubed to volume. You should know that a meter cubed is equal to 1,000 liters. That's just a conversion factor that you should know or be able to look up. And so we're able to write the molarity as 26,770 moles divided by 1,000 liters, and find that this is equal to 26.8 molar, capital M, zinc, where molar stands for moles for every liter.